Good afternoon, everybody, and welcome to the DRI Pavilion at COP30. The pavilion. Great. The pavilion has been set up by the Coalition for Disaster Resilient Infrastructure. We're a coalition of 51 countries and 10 international organizations with a specific focus on disaster resilient infrastructure. The reason we have this focus is because risks from climate change, extreme events are rising. Already we're in a position where the average annual loss to infrastructure around the world is $700 to $800 billion a year. This equates to 14% of global GDP we're at risk of losing every year. At the same time though, while there are extreme risks, we're also at a moment of opportunity. 75% of the infrastructure we will use in 2050 is yet to be built. And investing in resilience returns a dividend of 7 to 12 times this investment and can reduce GDP losses on a macroeconomic level by half. So we have an opportunity now to invest, to lock in resilience rather than risk. And so our core message across all of our sessions the whole week is very simple, that investment in disaster resilient infrastructure is one of the smartest we can make. Now, within that, there's obviously a lot of factors, a lot of issues, a lot of things that need to come together and can support the advancement of resilient infrastructure. One of those is the really high quality use of data and technology. And so at the CDRI Secretariat, to support the 51 countries, we have been working in consultation with our members to develop a data and technology strategy, which we'll be launching today, which aims to support our members to be able to collect, clean, and use data to be able to engage and access the best types of technology to support themselves. And just one quick example I'll give that where we've already been working in this space. Antigua and Barbuda last year held the SIDS4, the UN SIDS conference. The Prime Minister of Antigua, Gaston Brown, said one of the legacies that should come out of that conference was a SIDS global data hub. You know, everybody goes around the world and we're always saying there isn't enough data. The Prime Minister said we need to start addressing this. We're going to use this conference to start building a legacy where SIDS have access to data to support their resilience. And CDRI was able to support bringing people together at SIDS4 to launch that. And we've supported financially from our flagship program supporting small island developing states, generously funded by Australia, India, the United Kingdom, and the EU for the initial capacity building around that. So I'll stop there. I'd like to welcome all of you again. I'd like to thank our panel for joining, and I'm going to hand over to my colleague Suchasmita, who leads our advocacy program and managing all of our COP engagements over these 2 weeks, and she will take you through what I'm sure is going to be an excellent panel. Thank you.
Thank you, David, and welcome to you all. Thank you for joining us at the DRI Pavilion for what surely is going to be a very interesting discussion, because the topic of Earth observation for disaster management is extremely important, very topical, and I think there's a lot happening across the globe, which this is like the ideal platform to share the experiences and insights on. To begin with, we'd like to start with a video on the data technology strategy that we've put together, and we'd like to launch the data strategy first before we get into the actual conversations. Could we have the video, please?
Putting many vulnerable regions, including small island developing states, and least developed countries at risk. To address these risks, the world needs high-quality risk and resilience data, tools and technology. CDRI will leverage data and technology as strategic assets to enable our member countries make risk-informed decisions, strengthening resilience of their infrastructure systems and communities. Benefits for our member countries include timely access to geospatial and risk data, tools and technologies, assistance with infrastructure risk and resilience assessments, stronger institutions, awareness and deployment of technological innovations, Join us in accelerating exchange of knowledge, experience, and resources with our data and technology strategy for a resilient future for all.
Thanks, Kopal. And if we can just get the formalities out of the way, can we have a quick photograph of with the data technology strategy, and then we can get on with the panel, please. Thank you so much. Without any further ado, I'll quickly introduce the panelists. We have a group of experts who are going to bring great insights on the topic. I will not take any more time to talk about this because we have the right people here to discuss. We have Dr. Clement Albagel. He is the head of Actionable Climate Information Section from the European Space Agency. We have Dr. Hironori Maijima, Senior Chief Officer of Earth Observation at the Japanese Aerospace Exploration Agency. We have Mr. Rodrigo Fernandez. He's a Director of Sustainability at Bentley. Mr. Eric from AIIB unfortunately has not been able to join us. So we'll start the discussions with our esteemed panelists. And my first question would be to you, Dr. Clement. So technical capacity at the country level is key to success. To the extent to which Earth observation data and analytical tools and products are translated into tangible benefits. Can you tell us how recent advances in Earth observation and climate services has enhanced disaster resilience, and how effectively these tools are being benchmarked and adapted for use by ESA in developing country and climate service provisions?
Thank you. Thank you very much for the question. No, it doesn't work. Mic doesn't work. Is this one better? Thank you very much. At the European Space Agency, we build and design satellites. We manage mission, we organize the calibration, the validation, the distribution of the data, and we exploit the data. We exploit the data for Earth system science, for climate change, to develop digital twin of the Earth, and to address emergency response. We've been involved in the field of international development for more than a decade, for 15 years, and we've learned a lot through this journey. And I would like to tell you what we call the journey of the 5 A's. Historically, the main limitation for uptake of satellite Earth observation in developing countries for disaster emergency response, but not only, was availability and accessibility of the data. I strongly believe that programs such as Copernicus from the European Union or the USGS Landsat program from our colleague in North America have now solved this issue of access and availability. Everybody can have access to those data for free. Now that we've passed that, we move to what we call awareness, developing awareness together, working in partnership in development with the development finance community, first with the World Bank and then the Asian Development Bank, but not limited to. And we've raised awareness by co-designing and delivering Earth observation information product and user-oriented analytical tool. Once awareness was raised, we moved to acceptance. We had to create acceptance in countries for operationalization. And to do that, we had to go through what we call building capacity to use Earth observation-based information in day-to-day activity. And after acceptance comes adoption. Adoption via skill transfer to allow the local production and the local maintenance of Earth observation-based service, also resulting in growth of local digital economies. So through this journey of the 5 A's, we've managed to build a very strong community of users of our data worldwide.
Thank you, Dr. Clement. Very interesting points: availability and accessibility of data, awareness, acceptance, and finally building capacity and adoption. I think that's like a complete chain of what really needs to be done to be able to make data accessible to all. Just to follow up on that, if you could highlight a few best practices which are being followed by developing countries, and what should their focus really be in terms of data for building a resilient future?
Thank you. Excellent question. I can take an example of what we do in our activity on global development assistance. An example working with the World Bank. We've worked together to establish different needs with stakeholders in the client country. In South Sudan, we were contacted to help the government working on flood resilience. We developed a use case based on Sentinel-1 data. We looked at the occurrence of flood in the past 15 years to help the government build resilient infrastructure. This use case was then upscaled by the World Bank, who funded the same activity but at national level. And hopefully, the next step will be to extend to other countries. And doing that, we went through all those the last 3 A's, let's say, of this journey: awareness, acceptance, and adoption. We also worked on behalf of the European Commission to mirror Copernicus Data Center in elsewhere than in Europe. We have two activities. One not too far from here in Panama, the Copernicus LAC, Latin America and Caribbean, where we help countries to access to the data and to develop services based on this data. Copernicus LAC is one example. Another one is what we've built in the Philippines, COPFIL, and that we want to extend to the ASEAN country. Also, with the newly formed African Space Agency, we are going to develop specific partnership to help going from data accessibility to adoption and acceptance.
Very interesting, Dr. Clement. I think this clearly indicates the power of collaboration, working with the different agencies to really create that entire ecosystem that can take this forward. Extremely interesting. If I have the time, I'll come back with another question that I have in mind, but I will move to Dr. Hironori. And my question to you would be, could you please tell us about the Japan Space Agency's most successful and replicable models for demand-driven tools to improve the utilization of Earth observation? You have a presentation?
Yes.
Can we have the presentation?
Okay, thank you for the question, and I will use your presentation.
Just give us a moment.
Okay.
It's uploading.
So I'm Hironori Maejima from JAXA. So the JAXA is the Japanese space agency, and the JAXA conduct the research and the development of the satellite itself and the satellite data of application. And one of the application, one of the important application is the disaster resilience. So we developed some tool for the disaster resilience, and I will introduce about that. Let's go back to the previous slide. Okay, thank you. Okay, so the first one is the satellite-based global rainfall map. We call the GS map. It provides real-time updates every 1 hour at about 10-kilometer resolution. Based on the observation data since 1998, it can also generate statistical output. Today, GSMAP is being used by registered users in over 160 countries. Its operational use is steadily expanding, particularly among meteorological agencies in the Asia-Pacific regions. Next slide, please. Thanks. And recently, we have developed a new tool that allows each organization to calibrate GSMAP using their own local rainfall data. And we also plan to make this tool open source in the future. This approach is distinctive in that it enables each user's organization to perform GSMAP calibration with their own local environment. And this tool was developed in response to requests from user organizations. In that sense, it's a good example of the truly demand-driven development. The next chart, please. Okay, secondly, let me introduce the today's Earth. Yes. And today's Earth is jointly developed with JAXA and universities. Based on GSMAP data, it can simulate how rainfall flows across the land surface and the forecast river conditions all over the world. And today's Earth visualizes and outputs various hydrological variables, including soil moisture and river discharge. And we also work for practical demonstrations with the goal of achieving flood forecasting. And it can also be used as a tool to monitor river flow from upstream areas of international rivers, since satellite data can cross borders. The simulation model, today's Earth, is designed to meet the need for monitoring transboundary rivers, while taking advantage of the unique strengths of satellite, which can provide data seamlessly across the national borders. Today's Earth global is going to be updated at around 10-kilometer resolution this year. And ultimately, we plan to achieve a 1-kilometer resolution. It's very precise. We can very precise monitoring or forecast using the today's Earth. Next chart, please. Okay, the third one, I'd like to introduce here. It is a framework rather than the tool. So JAXA serves as the secretariat for Sentinel Asia, an initiative aiming at this space-based international cooperation for disaster management in the Asia-Pacific region. Sentinel Asia supports the entire disaster management cycle, but our main focus is on the disaster response phase. When the disaster occurs, we conduct emergency observations at the request from the member agencies and analyze the satellite data and provide the requesting agencies with estimated damage area maps. Accordingly, even the countries or organizations that don't operate their own satellite can quickly access observation and analysis data provided by member countries and regions. Sentinel Asia was established to meet the needs of the Asia-Pacific region, which is highly prone to disasters, and it is operated as a collaborative framework by multiple organizations. To date, it has conducted over 500 emergency observations and provided more than 2,000 sets of data, making a significant contribution to disaster management in the region. Okay, so that is the answer to your question.
Thank you. Just a small follow-up question on that. How do you think countries and governments can really mainstream infrastructure planning, emergency response and recovery strategies? You made very important points on the importance of demand-driven development, which you're sort of promoting through the work that you're doing. Also the point that it is important to really enable the user agencies to localize the information so that it can be more relevant to what they need. But in this context, if you can tell me a little bit more about infrastructure planning and how do we go about it, specifically in terms of the infrastructure?
Okay, thank you very much. So the answering to our question. So next chart, please. Okay, from our experience in Japan through Sentinel Asia, we believe that the 3 points are important. One is the raise awareness, and the second is the capacity development, And thirdly, the actionable information. And in other words, it is important to let people understand how satellite data can support disaster management. To facilitate capacity building for disaster management organizations and their non-space agencies to analyze Earth observation data themselves, and to provide simple, easy to understand, actionable information that is useful for the decision making. For example, aimed at the emergency response, JAXA has developed a fully automated analysis system to extract flood extending using JAXA's ELS satellite data. And since June 2022, the analysis results have been provided by Sentinel Asia. We can now provide the estimated flood extent map using this tool in 2 hours after receiving satellite data. So could you make a click once? Enlarge the map. Yes. You can see the very precise map, and this prompt response supports immediate rescue efforts as well as recovery and reconstruction planning. The next chart, please. Okay, next chart, please. Yes. So, in addition, we create emergency observation request history map based on our past emergency observation with the aim of supporting proactive risk assessment. These efforts are one example of actionable information. What matters is not just developing goods, products or tools. It's about building a framework to collaborate with the user organization involved in disaster prevention, increasing awareness, and engaging in dialogue with disaster response responders on the ground, facilitating capacity building so that they can utilize Earth observation data. It's also about continuously improving products and the tools on feedback from users about what information is truly needed. So we believe that this will ultimately lead countries and governments to mainstream Earth observation data. Thank you very much.
Thank you very much. I think very important insights on how Earth observation is also important for risk-informed decision making. So one is to manage the disaster and disaster management strategies, but also how do you use this to plan better and make your planning risk-informed. Thank you. Rodrigo, may I turn to you? How can we ensure that our infrastructure is future ready with use of Earth observation for climate and weather forecasting, digital technologies, community need? How do you take that into account, and what are the lessons that can be drawn from some of the things that are already happening across countries?
Hello, everyone. Pleased to be here. So I'm working at Bentley Systems. So Bentley Systems is worldwide, a global company leading software development for infrastructure engineers in any type of infrastructure and in any life cycle stage. So whether designing, maintaining, operating, planning, we support all those aspects, and the information we collect more and more. So when we talk about infrastructure, we talk about very accurate and very precise information that is relevant for us to do, right? In many cases, Earth observation is not so. Satellite data can be relevant in several cases and complements a lot of information, but in many cases we need in situ hyperlocal data that we can collect either with sensors that we put there in continuous way, but we can also use today with the advances of technologies, we can use drones that will take pictures and images. We can even work with LiDAR sensors that can map all that. Or cars, you can put the LiDAR in a car moving in a road and collect information and take advantage of trucks police cars. We are doing that in the US. Dash cams that you can have in cars, and you extract the information that is collected, so that you can then, using AI and computer vision, you can finding out where are the problems with the roads in terms of signaling, or if you have imagine a fire, wildfire, as it was in the US. Basically, we can take advantage of Google Street View as well. So all the information that is available online, we can basically use that information, compare with a car that goes there and collects images after the disaster. And by comparing before and after, the AI models can say, okay, there's a problem here. There's something here that needs immediate action. And so we can prioritize the recovery of the disaster faster. So there are so many ways. I think, I could keep here giving you more examples. I'm seeing my colleague from Sequent, the company from Bentley that works in the underground. So they are using technologies from Earth observation to detect water in places where there's no surface water at all. And I'm aware of projects where 1 or 2 million people in Tanzania now have access to water based on information that was collected 40 years ago by oil companies that were trying to find prospecting for oil and using information that was collected for oil, and in many cases combining information that was previously collected in situ with Earth's observation data and models, physical models. That's where the magic happens, right? Aggregating data, combining, filling the gaps that sometimes you have with Earth observation with accurate data. You can do much more and solve several problems, whether on floods, as it was presented, but also on droughts, on pipe leakage. For instance, in many cases, you can use satellite data to detect water leakage in pipelines. But also you can put sensors there and do machine learning and finding anomalies. So there's a vast, so many tools available right now. Some of them are expensive and they are not managed by the private sector, and that's what it is, right? But in other cases, when we talk about sending a drone to collect an image or images from an asset like a dam, and you can instead of having men in ropes inspecting a bridge or a dam, you can have generate a digital twin and a reality mesh model of the dam, and finding the cracks, detecting the cracks with AI, or having a technician in the other part of the world analyzing the dam without being in a rope, right? Or you can validate the information. You can still send someone and check if that's true. But it's a different level, right? You double check. It's different than do the real thing there on site. So there are tremendous opportunities. I gave you a few examples. I could give you more. I'm thinking I'm thinking in more examples. We are in Brazil, right? There was a project where there's in Maceió, Brazil, a salt mine with several risk of subsidence, and I think they also used information, Earth observation data, and 3D visualization models to better understand what was under the ground, what were the risks of subsidence of that salt mine, and when they identified the risks, the Environment Agency, I think it's a geological agency in Brazil, they basically they found the risks and they took a decision to evacuate people based on the information they collected. After a few years or months, I think the mine collapsed, and so they protected the lives of thousands of people that were in the risk area. So it's actionable decisions that can be made with the combination of Earth observation data with physical models and great visualization tools. I think visual communication is very important to influence the decision makers and the citizens. In many cases, if you're talking with experts and scientists, you don't need a 3D model to visualize. Sometimes you just show me the numbers and I will make a decision, right? But when you go to the top level or to the citizen, it might be a problem, right? Because they might not understand exactly what we are talking about. I just read the news today in Portugal. Just because of heavy raining, a couple old people died in the basement floor of a house because they were not aware that a heavy rain was coming up. So they didn't have access to the information. Facilitating access to what's going to happen, it's something that observation and digital twins and all this technology can facilitate. I hope I answered the question.
Yes, absolutely. Actually, you also answered the follow-up question that I had for you in a way, because we wanted to talk a little bit more about how this is helping at different stages of disaster risk reduction, and how can these technologies, and your very important point on combining satellite data technologies and also information source which exists from other sort of, there might be information available somewhere else and we might be reinventing the wheel every time, creating that data, creating that information again, although it might be lying somewhere, all it needs is perhaps updation, or it might be used as it is. So how can we basically use all of this to inform infrastructure investments? I think that may be the difficult part, because like you said, awareness is important, adoption is important, but sometimes when it comes to using this to really risk inform your infrastructure investment, are there any examples or anything that you would like to
Yes,
highlight?
of course. I think there's your colleague David gave the numbers in terms of $1 invested, you can get 7 to 12. The study, I think there was a study from World Resources Institute that was released a few days ago, exactly about that. And what we see, working in the private sector, we sometimes last year. Let me step back. Last year I was frustrated at COP because I was in some panels with investors, and they were saying that yes, we see the business case in mitigation, but in adaptation there's still the need to build the business case. And I was saying, how can you say that when we have so many examples and stories of companies, and I can give you 2 or 3 examples, you understand it. There was an accident in Kentucky in the US, floods. Several bridges were destroyed. And then basically they had to restore and to recover all those bridges. To do that, they had to find out what's the current state of the bridge, what actions need to be done, and prioritize actions. So to do all those inspections and monitoring all that information, instead of having people surveying all the data there, they basically used Earth observation techniques, drones and all that, collected information in a few weeks, and they accelerated the process so much that the numbers that they say that a project that was expected to have several millions in terms of acting just for surveying and identifying and planning and all that, they saved 90% of the investment just based on that. That's one example. Then when you extend the life cycle, the life time of an asset, let's say a dam, if it's projected for 50 years, in 50 years you might be doing another dam. But what if you plan for 100 years? If you do all the things that you need to do to ensure that it will stay with you for 100 years, and you can do that, before building, designing better, but also after building you can have early warning systems, better inspections, better maintenance, better response plans, and that will extend the lifetime of an asset, saving lots of money to the taxpayers, to the governments, and to everyone, and eventually saving lives. So there's the business case there with many examples. And we have also the private sector. We also have electric utilities, or private or public, depends on the country. This year, since we receive every year like 300 stories from users for an award that we give for best infrastructure projects, this year we got lots of stories and projects from electric utilities around the world. We have examples in China, in Spain, in Australia, are now building early warning systems for floods in their substations using a combination of our technology with other sensors and other models, and basically they are trying to protect their assets because there's a business case there. If they lose their assets, you can imagine the money that they are just losing, and they know the risk is there. So yeah, the business case is just there in front of our eyes.
I think very important point on creating the business case, and more importantly, I think it's useful to start talking about this more often because there's so much there. I mean, there's so much that you're telling us, but then still, when you think of AI and Earth observation, it would still be, there's research happening somewhere, but how do you really translate that research to policy and practice? And on that, I have a question, a final question from my end, and I can open it up to the audience for questions. On your point on collaboration, so there's a lot of collaboration that you're doing with different space agencies, etc. Very briefly, what are the challenges? I mean, what is the two big challenges that you really face in making all of this happen?
I will pick up on a point you mentioned earlier about not duplicating the wheel. This morning I was discussing with the director of hydrology at WMO, and we were talking with stakeholders in Ethiopia. And apparently, every now and then, people create a new platform, a new runoff model to develop river discharge in Ethiopia, because they all want to develop their own and to be the best. So collaboration is key, but it can only be a true collaboration if we listen to each other and if we build that together. And a very good example in satellite Earth observation community is the work done under the CEOS, the Committee on Earth Observation Satellites. Najima-san and myself were together in one of those meetings last week in the UK, and that's where you learn what the others are doing and see how you can add your information. So I will praise collaboration, stronger collaboration, and I think that if we also want to go to the next step in resilience infrastructure, we really need to combine Earth observation, satellite or not, with societal information to really unleash this power. There is a flood in a town. You need to know which building have been flooded and what is happening in those buildings to know which sector of the economy are going to be stopped. If a school is flooded, the kids are going to stay home, the parents are not going to work. You need to access all this information to be able perhaps to monetize the information.
Very important point. I think that's something that we don't talk about much. How are you taking that information and really connecting it to the people on the ground? But end of the day, all these efforts are to safeguard those at risk. Can I take your thoughts on the same question on collaboration?
Okay, thank you. So as Clement mentioned, yes, I agree, totally agree that. And yes, the system is very important to integrate all information or all assets or all tools. Now the technology advanced and we have many tools. The satellite and ground-based instrument and drone and space aircraft, helicopter, like that. And they integrate all the system, all the data is very important, and to produce the information. And the next, I'd like to point out that is the importance of the timeline. So we are now let's say considering the making a system using considering the timeline. So first of all, we will use the satellite data. It is the very observed simultaneously very wide area. And then we will focus. This area is damaged, and the helicopter or very small satellite will observe that. And then we integrate these data, and of course they are using the analysis. So the integration and the system is very important.
Thank you. We have some time and we can take some questions from the audience. So could you please identify yourself and to whom your question is addressed, please?
Hello, my name is Camilo Prats from Chile. I'm from a consultancy company. I used to work in adaptation plans with local governments, things like that. So we use a lot of all the information and tools that you develop. So I have a question to Rodrigo, and it's related how you are mixing or integrating this Earth observation data and digital twins and all the software development that you are doing daily. Thank you.
Okay, so I think in many cases we don't integrate, we facilitate the integration. So we provide the tools so that the end users are able to federate the data. And when I say federate, because indeed they don't need to download the data to our system if you want to have access to it. They just need to connect the dots. They need to connect to map and index where it is, and if it's in a appropriate format, and I will go to formats in a second. But if it's in an appropriate format, we try to facilitate technologies where you can aggregate, federate the data, and then extract the insights. Because data, it's not enough, right? You need the insights. And so we focus more in federation and visualization, but also on generating the insights, right? So that's what we try to do. So we are not consultants. We are software developers, so we rely a lot on our on engineering firms and consultancy companies, or even asset owners that might have the experts and the champions there to do the things. But of course, and by focusing on that, by focusing on facilitating the way to make the integration, means that we do what needs to be done. We working globally, we find that to make an integration, you need standards. We need formats that are based on an open standard as much as possible. And for instance, I'm proud that, for instance, our cesium technology, which basically it's a library for 3D viewing. If you open any Google tool and you visualize something from Google in 3D, you don't know, but it's cesium technology from Bentley that is using for rendering modeling, and I'm not only proud by that, but also proud that ECMWF, which I think it's from the Copernicus system in Europe, their Destination Earth project for a digital twin of the world, they are using cesium as well as for visualization of data. So we try to enable and to empower people to do integrations as much as possible, rather than doing it ourselves. But trust me, standards and open data is important. Otherwise, we are speaking English right now, right? Because English is an open language that people adopted as a standard. If I speak in Portuguese here, I think we are not going to do an integrated conversation as much as possible, right? So, yeah.
Thank you very much for a very interesting session. My question is that data sharing is not exactly coming very easily to governments. And infrastructure data itself is a very, you don't openly share it. There are some safety concerns and international issues that one would like to share. But the impact of hazards, for example, upstream, have an impact on a country's infrastructure assets downstream. Now, in which case, you are scientists and you are developers and you are working in this technology field. You see it very differently. Now, what are the sort of messages that you would want to give out to the governments so that this actually becomes a reality, both in terms of data sharing and easier access to data for this kind of assessment and analysis, and then transferring it to the communities to take action? And also another question linked to it is, we've come far for using early warning system for saving lives, for example. But what does early warning mean for infrastructure? I mean, you can't really shift an asset, but what is the sort of preparations or things that infrastructure needs to take, infrastructure operators or managers need to take care to ensure that there is reduction in the damage caused to the. So that is not very clear in terms of how does EWS translate to infrastructure as opposed to communities and lives and saving lives, which has come far. So this is my question. It's a little abstract, but maybe any of you could be.
I can take it. I just want to monopolize the discussion. But so I think again, yeah, you're asking for advice, right? So again, we don't own the data, and we don't own the models. We, as I say, we enable the technology so that you can integrate the data. But the data is yours, or your data is your data. For instance, we use AI, but we make sure that the AI is used with the data that is still ownership of the user. Now, if the government decides to keep it closed data, what can we do, right? We work with different governments in different parts of the world, and I'm not going to put names here. And some governments decide on, or particularly local governments, decide to create ecosystems, sharing data with all citizens, and then might have the private sector doing businesses on that and all that. So they create things on that area. But then you go to other cities or other countries, and indeed they prefer to keep it all on their way. And we don't have a decision making on that. If you ask my advice, I think I think they should open the data as much as possible, unless there's really sensitive information from a business or a safety or security aspect, and that should be probably also standardized. We are at COP30 discussing, this is United Nations. All of the countries except probably one or two are not officially supporting this, but couldn't we define the type of data that is critical for citizens and for early warning systems? Maybe we could, maybe we should. That would be like the minimum viable data that should be shared. That would be something. The other thing I think you had another question, which is how early warning systems could materialize or could be instrumental for infrastructure, which you say you are uncertain. I can give you, I don't know, I can pick one industry. The water sector, for instance. If you get an early warning system, for instance, finding out when there's a big pipe burst that will affect water supply for citizens in an area because of a flood or because of something like that, if you can detect the problem earlier using AI and Earth observation and models, then you can act, you can even use models to predict what are the areas that will be affected, and then you can act promptly. And in many cases, acting 1, 2, 3 hours faster can make a huge difference on this situation. So that's one example. But I could give, if you give them another sector, I can give you other examples.
Thank you. I echo to what Fernando just said, and I think that we need to continue to open the dialogue, particularly working with government. I think the story is, if your only tool is a hammer, then it's easy to make everything look like a nail. So you've got the tool. Local administration they like census and tables with number. We just have to open the eyes about the potential of satellite Earth observation and two-dimension activity. And I think that we need to continue to engage in this dialogue on early warning and on infrastructure adaptation. Satellite Earth observation are used when a town wants to build a dam and look at climate adaptation. You need this type of information to understand how high you need to build your dam. Or with satellite Earth observation, you can study long-term series of coastal erosion and or accretion. And when you do that, you can also combine with flood models to look at the impact a specific event, a storm, a tidal wave, will have on the nearest infrastructure. And then you know which building are the more at risk if this happens. And you define scenarios. And based on those scenarios, you can then plan better.
Yeah, so I'm sorry, just 10 seconds. Also, another example that came to me. when we talk about structural integrity on infrastructure, that's also very important. So you can have in situ sensors in roads and other critical infrastructure for detecting landslides earlier than happen, because the indicators will give you information. And the same with satellite data with INSAR technology. You can find ground deformations that can signalize a potential catastrophe in a dam or something like that. So early warning systems on that, it's really key and critical.
Dr. Hironori, would you like to?
This may be a view from the spacecraft developer, and I think there are three layers. One is the data provider, and the second layer is the analyzer, and the third is the user. So the data provider should promote the interoperability. So the many data format in the world. So for the analyzer to use data more easily, so we have to make interoperability, and then analyzer will analyze the data for user to easily use. So then the decision maker or users can easily use our data.
Thank you very much. Very useful insights. If we do not have any more questions from the audience, maybe we can close the session a little early, but not before I try and summarize what I am taking away from this session. There may be a lot more. We heard some great examples of what's happening already and what are the possibilities, but I think the key headlines for me would be it's important to make the data accessible, interoperable, to be really impactful. The 3 A's were very interesting and a great model: availability, accessibility, awareness, acceptance, and then adoption. The importance of demand-driven development and the need for localization to really make it impactful. The need to collaborate and share data and information so that we do not reinvent every time, but we are using what exists, update it, and use it to the best possible way. Also the importance of the business case and to share these best practices so that we know what's happening across the globe. We can collaborate, network, and sort of share experiences. And finally, the integration of technology, Earth observation, AI. I think all of that coming together is really going to make the impact that we're looking for in terms of risk-informed planning. So you prepare even before the event really happens. Thank you so much to the esteemed panel. It was great having you, and thank you to the audience for being with us. And we look forward to seeing you at the other sessions that are going to happen today. Thank you so much.